Very good evening to one and all. So we were discussing about the different actuation systems used in mechatronic system, and we started discussing different type of actuation systems. And I told you, so in this part we are mainly concentrating on the pneumatic as well as the hydraulic actuation systems, and we discussed about the hydraulic and pneumatic system, and we were discussing about the different parts of a pneumatic actuation system. And if you look at the pneumatic actuation system, this is actually a line diagram which represents the pneumatic actuation system. Here you can see different parts like filter, silencer, a motor, compressor, a pressure relief valve, a cooler, a filter and water trap, and an air receiver. And we already discussed about the different parts of this pneumatic system, isn't it? And we have seen that the compressor, which is the very important part of a pneumatic actuation system. So as the name implies, in the case of a pneumatic actuation system, it utilizes the compressed air. So the compressor forms the major component of a pneumatic actuation system. Now there are different type of compressors used in a pneumatic actuation system. They are reciprocating compressor and a rotary vane compressor and the screw compressor. These are the three main types of compressors which are used to achieve the compressed air in actuation systems, pneumatic actuation systems. First, let us look into the single acting, single stage, vertical reciprocating compressor. Actually, this shows a schematic diagram of a reciprocating compressor, and I will explain how this is going to work. So here initially there is an intake stroke, I mean the air intake stroke, and what will happen is the piston will come down or and causes the air to be sucked into the chamber through the inlet valve. And if you look at the inlet valve which is a spring loaded valve, and now through its inlet stroke the air sucked into it, and when the piston starts to rise again, the air which is trapped, I mean the trapped air, forces the inlet valve to close and to become compressed. I mean on the way back, on the way back, I mean when the piston starts to rise again, the trapped air which forces the inlet valve to close and the air gets compressed. And when the air pressure reached a particular limit, the spring loaded outlet valve opens. I mean this one, the spring loaded outlet valve opens, and the trapped air, I mean the compressed air, flows into the compressed air system. So here you may please note that after the piston has reached the TDC, let's use the terminology like that, top dead center, it then begins to descend and the cycle, and it repeats the cycle. So such a compressor is termed single acting because one pulse of air is produced per piston stroke. Now what would be then double acting compressors to produce the pulses of air on both up and down strokes of the piston. And it is also called the single stage because the compressor directly goes from the atmospheric pressure to the required pressure in a single operation. So it's a single stage compressor. And generally for the production of compressed air in most of the pneumatic system, you can see that two or more stages are generally used. Normally two stages are used for pressure up to about 10 to 15 bar, and more stages are required for higher pressures. So thus when a compressor um, for a two-stage compressor, let us say like um, how does it compresses the air is initially the air from the atmosphere is taken and it is compressing, it will compress the air to say 2 bar, and then the second stage compressing the air to say 7 bar. So by different stages it compresses. And if you look at the diagram, you can see that a reciprocating piston compressors, not from the diagram, the reciprocating piston compressors can be used as a single stage compressor to produce air pressures up to about 12 bar, and it is used as a multi-stage compressor to produce pressure up to 140 bar. And you may please note that the air flow deliveries tend to range from 0.02 meter cube per minute free air delivery to about 600 meter cube per minute free air delivery. So when I mean free air delivery, the free air is a term used for the air at normal atmospheric pressure. And another important type of compressor which is used in a pneumatic system is a rotary vane compressor. You can see a nice schematic diagram of a rotary vane compressor. And if you look at the diagram, you can see that the rotor, this rotary vane compressor has a rotor mounted eccentrically in a cylindrical chamber as shown in this figure. The rotor has blades, they are called the vanes, which are free to slide in radial slots with rotation, causing the vanes to driven outwards against the walls of the cylinder. So as the rotor rotates, the trapped air in the pockets which is formed between the vanes and the rotor casing. Okay, as the rotor rotates, the air trapped in pockets formed by the vanes and the rotor um, sorry, there was some trouble. Okay, so as when the rotor rotates, the air is trapped in pockets formed by the vanes and the compressor, and the air is compressed. Okay, so the compressed packets of air are thus discharged from the discharged port. So here a single stage rotary vane compressors typically can be used to for pressure up to about 800 kPa with flow rates of the order of 0.3 meter cube per minute to 30 meter cube per minute free air delivery. Another form of compressor is a which is shown next, that is a rotary screw compressor, which is commonly used in pneumatic actuation system to compress the air. So if you look at the diagram, you can see that two intermeshing rotary screws which rotate in opposite directions. So as the screws rotate, the air drawn into the casing through the inlet port, you can see the air is drawn to the compressor through this intake port and the space between the screws, and then it flows into the space between the screws. So, and this trapped air is moved along the length of the screws and compressed as the space becomes progressively smaller, and then it expels to the from the discharge port. So typically the single stage rotary screw compressors can be used for pressures up to 1000 kPa with a flow rates between 1.4 meter cube per minute and 60 meter cube per minute free air delivery. Thank you.